There is a place in our galaxy where something impossible seems to be happening. A cloud of gas and dust, cold, dark, and emptier than any vacuum we can create on Earth, is slowly, quietly building a star. Not in a flash, not with an explosion. Over millions of years, out of almost nothing, gravity is sculpting a furnace 1,000,000 times more massive than our entire planet. The question is, how does something so empty become something so violent? By the end of this video, you will understand exactly how that happens. And the answer involves forces so extreme, so precise, that the fact you exist at all is part of the story. Our galaxy is full of clouds, not water clouds like the ones above your head. These are molecular clouds, vast regions of hydrogen gas and dust that drift through the arms of the Milky Way like slow, dark fog banks. The most famous of them, the Orion molecular cloud, is so large that if you could see it with the naked eye, it would stretch across a patch of sky 40 times wider than the full moon. These clouds are unbelievably cold, around -260 degrees Celsius, just a few degrees above absolute zero. They are also incredibly thin. A cubic centimeter of this gas contains only a few hundred molecules. Compare that to the air around you right now, about 27 million trillion molecules in the same space. And yet, these clouds are the birthplace of every star you have ever seen in the night sky. For a long time, a molecular cloud just drifts. Gravity is pulling it inward, but internal pressure and heat are pushing back. It is a stalemate. Then something disturbs it. It could be a nearby supernova, a dying star that explodes and sends a shockwave rolling through the cloud like a ripple across water. Or it could be the gravitational nudge of two spiral arms of the galaxy passing close to each other. Whatever the trigger, it tips the balance. Parts of the cloud begin to compress. As the gas gets denser, gravity strengthens. And as gravity strengthens, the gas compresses further. This is the moment a star begins to be born, and it cannot be stopped. As the cloud collapses under its own gravity, it does not fall inward as a single blob. It fragments. Different regions inside the cloud collapse faster than others, and each fragment begins its own collapse independently. This is why stars almost never form alone. One molecular cloud can birth hundreds, sometimes thousands of stars at the same time. Stellar nurseries, and some of the most beautiful images ever captured by telescopes, the Eagle Nebula, the Carina Nebula, are these nurseries lit up by the very first stars they just made. Inside each collapsing fragment, something important is happening. As the gas falls inward, it picks up speed. That speed converts to heat. The core of the collapsing cloud gets warmer. At this stage, it has a name, a protostar. It is not yet a star. It cannot produce energy the way a star does. It is just a hot, dense, glowing ball of gas, still feeding, still growing, still falling inward. Here is something that seems strange at first. The cloud is collapsing inward toward a central point, but it does not collapse in a straight line. Because the original cloud was slowly rotating, even just a tiny amount, as material falls inward, it spins faster and faster. Think of a figure skater pulling their arms in. Same mass, smaller radius, faster spin. The infalling gas forms a flat, spinning disk around the protostar, called an accretion disk. This disk is not just a byproduct, it is where planets come from. The same process that builds a star seeds the raw material for everything that orbits it afterward. Material from the disk rains down onto the protostar continuously, adding mass, adding heat. The protostar grows, the core temperature climbs. For tens of thousands of years, this continues. There is a number you need to know: 10 million degrees Celsius. That is the temperature at which hydrogen nuclei, bare protons, are moving fast enough and are packed tightly enough that they can overcome their natural repulsion and collide. When they do, they fuse. Two hydrogen nuclei merge into one helium nucleus, and in that process, a tiny fraction of their mass is converted directly into energy. This is nuclear fusion, and the moment it begins in the core of a protostar, everything changes. The energy released pushes outward against gravity. For the first time, there is a force strong enough to stop the collapse. The protostar stabilizes. It is no longer a protostar. It is a star that was, not long ago, a cold, dark, almost empty cloud of gas floating through the void. When a star first ignites, it is violent. Intense radiation and stellar winds blast outward, pushing away the remaining gas and dust that haven't yet fallen in. This is called the T-Tauri phase for stars like our Sun. The young star is active, unstable, throwing off enormous flares. Over millions of years, it settles down. What gets left behind depends entirely on the mass of the star. A star similar to our Sun will burn steadily for roughly 10 billion years. More massive stars burn hotter, brighter, and die far faster. Some live only a few million years before exploding as supernovae. And when they do explode, that shockwave travels outward through the galaxy, compressing the next cold, dark cloud, starting the process again. So here is the answer to the question we started with. How does something so empty become something so violent? Gravity. Time, a small disturbance. The cold gas falls inward, fragments, heats up. A disk forms, mass accumulates, temperature climbs to 10 million degrees. And fusion ignites, turning what was nearly nothing into one of the most powerful ongoing reactions in the universe. The star that lights your sky right now, our Sun, was born this way, roughly 4.5 billion years ago, inside a molecular cloud that no longer exists. The atoms in your body, the carbon, the oxygen, the iron, were forged inside stars that came before it, lived out their whole lives, and died, seeding space, with the material that eventually collapsed again, and became the cloud that became the Sun, that became the Earth that became you. Stars are not something separate from us. They are where we came from. Every single one of them started as an almost empty cloud of cold, dark gas. And gravity did the rest. If that blew your mind a little, subscribe. There is a lot more where that came from. Next time, we are going inside a star that is already dying and asking what happens in the final hours before it tears itself apart. That one is not to be missed.